Number 5. You throw your calculus book from a 1,500-foot cliff. Sounds like a lot of fun. The height of the book over time is modeled by this function here, okay? And it's h of t, and we've got 1,500 minus 16t squared, where h is the height of the book, and t is the time in seconds. Fine. Find h prime of 3 and explain the meaning. Okay, well, let's find h prime first of t, and then we'll find h prime of 3. So we got just negative 32t, taking the derivative of this function, and that's what's nice when you are just dropping things. Okay, when you're just dropping things, the equation comes out very simple. We're going to plug in a 3, and negative 32 times 3 is going to be negative 96, and that's going to be feet, and that will be feet per second. So interpreting the meaning is that the book is falling at a rate of 96 feet per second, right? So we know it's falling because it's negative, okay? So it's going pretty fast right there after 3 seconds. However, let's look at the second derivative here where it says find h double prime of 3. So we will take the second derivative, and it's going to give us negative 32. Ouch, it's got a big pain in my ankle there. And it doesn't matter what we plug in, it's going to be constant. Okay. So this negative 32, what is the meaning? It means that the rate in which the velocity is changing this is kind of wordy though, is increasing. Right, well, it's decreasing, but since they're both negative, they're both going in the same direction. Okay, so not the velocity, we'll say the speed is increasing by 32 feet per second. So yeah, I mean, that's the acceleration of gravity, is negative 32 feet per second, and we're going to say squared, right? Okay, so 32 feet per second per second. Okay. All right, the graph of the velocity of an object is shown here. You can see here the v of t. This is time. And let's see, they give us that, which we knew. When does the object reverse direction? It reverses direction when he was positive and then he goes negative, or when he's negative and goes positive. Now that always occurs right here at these points here. This is when he's positive, it becomes negative. So at t equals 2 and at t equals 10. Okay. The v of t is greater than 0, and then is not greater than 0 for t of 2, and this guy v of t is negative and then goes to being positive. Okay, so I just kind of wrote that in just mathematical expressions there, and I think that's fine for a review like this. All right, so hopefully that was pretty clear. Now this guy, and at 0, he doesn't change direction. He actually, we could say here that he is officially at rest because nothing happened before, nothing happened after. We know that he was at rest for that moment and then switched his direction, but it was only for a moment. Here it looks like he stopped, like somewhat permanently. When is the object moving at a constant speed? Well, there we're going to look for flat lines where there's no slope on velocity. Okay, so we see it right here between 4 and 5. Okay, and we see it at 12 to 13. Okay, so those are the spots where we see that he's on cruise control. Okay, what is the object's maximum speed? Okay. Okay, now if it did say velocity, we would have to go with this guy because this is his positive and it's at 4. But if we're going to talk about speed, then we don't care what direction he is going. So he was at this moment right here going -6. Okay, and even though he's negative, it doesn't matter when we're talking speed. So what is his speed? It would have been 6 meters per second. Okay. If you wrote negative, I would mark it wrong, but you're kind of saying that it's velocity. Okay, so take the absolute value of velocity whenever you're talking about speed. Okay. All right. Yeah, velocity and speed is just always such a difficult thing for me in high school. So, at what time interval is the object speeding up? Okay. So here's where we are looking to make sure that velocity and acceleration are working together to go both to the right or both to the left. Okay. So we are looking for when velocity is positive, the slope has to be positive, and when velocity is negative, the slope has to be negative. So where is that happening? It's happening right there, okay, from 1 to 2. Okay, it's happening, well, here from 2 to 4, he's negative velocity and he's going down. So from 2 to 4, he's speeding up. Then he goes constant. Then from 5 to 7, he's actually increasing again. Okay, so then he's moving towards the left, but his acceleration is slowing him down until finally he comes to a stop, and then he turns around and starts to go. He starts to speed up again. So from 10 to 12. All right. Oh, 10 to 12. And at that point, that's it. These are the 4 instances where this object is actually speeding up. Okay? And the justification is kind of what I just said. I'm going to skip writing it. But remember that because the velocity, and I'll write it for one of them. The velocity is positive and acceleration, or we can say V prime of t is positive. Okay, this right here is positive, positive. This guy's going to be negative, 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 positive, positive. Okay, so something like that. All right, so we got the function here, d of t equals this guy, models the depth in feet of water after 5 a.m. Find the instantaneous rate of change at 8 a.m. Okay, so this is the function. What we're looking for is if we are at 5 a.m., okay, we're going to look at time 3. Okay, 3 hours later. Okay, we'll worry about the units in a second, but at 3, how is the depth of the water changing at that moment? Okay, so what we're going to do is, I don't see a calculator symbol here. We could do this by hand, but for our purpose, you're going to need a calculator anyway, because what is it? It's going to be negative 2.8 sine pi over 4t times pi over 4. You got to do it, but with a calculator here. So let's just go ahead and do the derivative. Now we can go to math. Okay, so maybe write math button on here. Okay, and we're going to actually use it for here too. Okay, we're going to use the derivative function on our calculator. So we're going to go to derivative 8, or just push 8. And we're going to do it in terms of x, but we could do it t if you feel safer that way. T is actually alpha. Yeah, this is why I just use x. But t is actually alpha. Where are you? Alpha 4. Okay. But then it says t equals. See how they switched that? That's kind of cool. But let's just go ahead and do 15 minus 2.8 cosine. And then in the parentheses is pi over 4. Divided by 4 times t, so alpha 4. So make sure that you keep that t consistent. And what we're going to do is we're going to go ahead and plug in when t equals 3. Okay. Now it's taken the derivative and it does it instantly. So it's 1.555. Okay. So what we're saying is d prime of at 3 equals 1.555 what? Well, it looks like it's in feet per hour. Okay, so remember that if we take the derivative, we're going to get a rate. So this guy means that at 3 hours, the depth is actually changing. It's getting deeper by 1.55 feet at that moment, right after 3 hours at that moment. So we could expect that with the next hour, the depth is going to be 1.555 more once we get to T4. Okay, so right at that moment. Okay. All right. So now we got another one. Denise uploaded a funny video on her Tiki platform. It is gaining views and likes rapidly over time. The function is here. What is the instantaneous rate of change in the number of views 4 days after the video was uploaded? Okay, so we're going to do the same thing. We're going to go ahead and go to math. We're going to go to derivative. We're going to go ahead and just use, let's just use x. Then we're going to go 120. So it looks like she started with 120 views right at the moment. Right at, yeah, at the first day, or right at that time 0, she had that many people. 0.75, okay. X, and yeah, that's it. All right. So we want to find it at 4 days. So let's just make sure the function is gaining views and likes rapidly over time. 4 days after video is uploaded. Okay, so it doesn't say that this function is in days, but let's assume that it is. So we're going to say 4 days, and we got 326.7, and it's going to be at 4. 326.7 what? So it looks like this is increasing at a rate of 326 views, almost 327 views per day. So we do expect that at day 5 she would have 326-ish more views. Okay, so that's that.